Hello, Code Camp, and hello, Romania, and hello, the rest of the world, and YouTube, and everyone else who's tuning in. And yeah, it's nice to be back, doing a lot of online events, and certainly we as an industry seem to be getting the hang of it. And today I am going to talk to you about architecture, the stuff that's hard to change. Now, you can see some architecture here in this slide. This is not real architecture. This is Lego architecture. This is easy to change, but like software architecture, it is very, very expensive. But I quite enjoy buildings. I like Lego. I like building things with code. And so that's kind of a nice way of kicking it off. This is me. Dylan Beattie. I'm a Microsoft MVP. I run the .NET user group here in London. And I also, some of you may have heard of my most successful joke project, Rockstar, the comedy programming language that turned into a joke with a reference implementation and a formal test suite. But if any of you have ever wanted to be a Rockstar developer so you can go and apply for all those sweet jobs on LinkedIn, go to codewithrockstar.com, type in your code, and if it passes, congratulations, you are a Rockstar programmer. And about probably 6 or 7 years ago, I was at work, I was running a software team here in London, doing all kinds of stuff. And we got some consultants in to do one of those, restructuring kind of things and help us make some changes and figure out how to grow the company and all that kind of stuff. And one of the things they came in and they looked at the people we had on the team and they said, we think you should probably become the architect for this team. And, I'd been a programmer and a manager and done bits of project management, all kinds of stuff. I've never been an architect before. And I got this email from my boss saying, this is to confirm your change of role to systems architect. And you are responsible for architecture, architecting, doing architect stuff, systems architecture and architecting systems. Congratulations on your new role. And I went back to my desk and I sat down. I was like, I'm an architect now. Okay, this is cool. And, it didn't feel any different. It's like the Visual Studio was still kind of slow to load and I was still finding bugs and all these kinds of things. And, I realized that I wasn't entirely sure what this architect role entailed. So I figured, hey, if I'm the architect now, I should probably work out what my job actually is. Now, in software, we steal words from all over the place. And if you listen to two software developers chatting, like, you ever hear two software developers in the airport and they're in the bar waiting for a flight and they're talking about, oh, we had a really bad crash on launch. And you're like, don't say those words in an airport. Like, those words mean something in our domain. We talk about launching applications and crashes. They mean something different. And, we have conversations about a Python having a problem with the mouse. And if you're a zookeeper, then that's a completely different thing. And, we talk about buses and pipelines and all these words that we steal from the English language and use them to mean something different. And then we have this word architect that we borrowed. Now, there is some controversy about architect because the word architect, the only other place I've ever encountered it is in construction. And in construction engineering, in buildings, there are engineers and there are architects, and there's a kind of pretty clear understanding of how those two roles delineate. And actually, there's this question that comes up a lot when you talk about software is, what are we? Are we, just drop a couple of messages in the YouTube chat here. What do you call yourselves? Are you hackers? Are you coders, front end, back end, developers, all these kinds of things? How many of you out there have the title engineer? Because there is this controversy going on. Programmers, stop calling yourselves engineers because, it depends where you are in the world. There's this serious discussion. In Canada, you need a license to be an engineer for anything, including software. In New Zealand, if you have a university degree that has the word engineer in it, then you can call yourself a software engineer. So if your degree is in, say, computer science, you're not a software engineer. Here in the UK, my cable TV went out a couple of weeks ago and they sent an engineer and guy turns up in a van with this big drill bit to punch holes in the wall. I don't think this person had an engineering related degree, but they fixed the cable, so I'm sure they're doing their job, But let's try this as a definition, right? If you're building a barbecue in your backyard, like the one you can see here, this project was probably implemented by the person who designed it. Maybe they designed it on paper. Maybe they just started stacking up some bricks. But, there's definitely a hands-on implementation. Whereas the Brooklyn Bridge here in Manhattan, in New York, well, one end's in Manhattan, the other end's obviously in Brooklyn. The Brooklyn Bridge was not built by the person who designed it. And maybe that gives us an interesting kind of definition. Architecture is the point where you are involved in creating software where you are not going to be the programmer, or you're not going to do any of the programming. You're going to be designing systems that will be implemented by other people. Now, in construction architecture, we have all of these amazing examples all over the world of, architecture as a discipline that we study and we can learn from, and you can go and look at them and be like, wow, that's really cool, and copy patterns and all these kinds of ideas. But we don't really have that in software. We don't have great software projects that we go and do tours of the architecture and show people how they work. Let's dig a little bit deeper. Now, the term software engineering, this idea of engineering in software, it goes back to this lady. This is Margaret Hamilton. Margaret Hamilton led the team who built the guidance software that took Apollo to the moon. And she was a very strong advocate of something called the systems view. She's like, the Apollo program, it's not just hardware and then we put our software on top of it and we launch the thing. And they really did launch software, But she was saying, the software is a system, like the hydraulic system, the navigation system, the guidance system. All of these systems need to be aware of the capabilities of all the rest so that they form a holistic unit that will do the job that it was designed to do. So, there's this idea of engineering. She was the first person who treated writing software as an engineering discipline. And there's a saying, writing code doesn't make you a software engineer, just like laying bricks doesn't make you a structural engineer. There is a degree of thought about the way software works here, which transcends just writing lines of code one on top of the other. The first person to talk about computer architecture, first person to use the word architecture in reference to a computer system, was this guy. This is Fred Brooks. He wrote The Mythical Man Month, very, very famous book, collection of essays about software. And in 1962, he wrote these words. He said, "Computer architecture, like other architecture, is the art of determining the needs of the user of a structure and then designing to meet those needs as effectively as possible within economic and technological constraints." Now, for a long time, computer architecture meant hardware, because hardware was the stuff that was expensive to change. If you needed to change the code, you just change the code, edit it, deploy a new one. Now, it might be a complicated change to the code, but compared to the cost of changing something like the bit width of a microprocessor, you're talking about, we need a new factory, we need new assembly lines, we need new tooling, we need new everything, we need new interfaces and circuit boards. Oh yeah, and we need to update the software, but that's kind of the easiest part of all this. Now, I think that the reason why we started talking about software architecture in about the 90s is where this kind of dates to, was for, two reasons. Up until the mid-90s, most businesses didn't care about the cost of changing software. The vast majority of businesses, if you had software at all, you bought it, you ran it on the computer in the corner, you printed out your spreadsheets and reports, and you got on with your life. The software wasn't your problem. Maybe after a couple of years, you'd buy an upgrade for it. Then two things happened in the 90s. The first of them, Visual Basic. Visual Basic comes out, and suddenly lots of businesses that never dreamed of being software developers were like, well, we can hire someone to build an application to do this for us. We can hire someone to build a stock control system for our, our car repair shop or whatever. And so suddenly lots of small businesses were like, we've paid someone to automate our office, and then they're like, oh, we need to change it. And of course, the programmer says, oh yeah, well, change of request is going to cost you $500. And suddenly all these businesses are like, what? It costs money to change the software, but we thought it was software, And so this understanding of the cost of changing computer code started percolating into our global consciousness. And speaking of global consciousness, boom, the World Wide Web comes along. And along with all of the other astonishing things that happened as a result of the web meant that for the first time, companies could deliver value without physical products or physical presence. You could create software as a service, or you could do digital downloads. All of these new kinds of business became possible, which meant we started seeing companies that they had no stock, they had no, plumbers or electricians or hairstylists. All they had were developers and marketing. And so their entire line of business, 80–90% of the cost of that company existing, was paying software developers to maintain and upgrade the software. And so within a fairly short space of time, people started thinking really, really hard about managing the cost of commitments to software projects over a period of time. And that's where, you know, we kind of get the stuff that's hard to change. Because a lot of stuff in software, change the button from blue to red. If you've built it well, yeah, that's easy. Blue, red, bang, deploy, you're done. The stuff that's hard to change are the things, if you get it wrong now, it's going to be really expensive to deal with later. Now, in 1995, this book came out, Software Architecture. This is kind of where the phrase software architecture arrives. This is Mary Shaw and David Garland, and they described this book as an attempt to catalog a substantial folklore of system design. Lots of people were thinking about this stuff. They weren't really, we didn't have the vocabulary to talk about it between ourselves. People were writing essays and things, and this was the first real attempt to bring all this stuff together and say, this is what we think software architecture is. This is what we're talking about. Let's go back to Fred Brooks' definition. Now, you know, I like this and I want to use this as a starting point. Fred says computer architecture is the art of determining the needs of the user, designing to meet those needs within economic and technological constraints. Now, who are your users? You know, it's designing to meet the needs of the user. Who are these people? Well, when you're doing architecture, your users are developers. They are the people who are writing the code that is going to ship to your customers. Those are your users. But it's not just the users you've got today. It's the users who you haven't hired yet, to build the products you haven't thought of yet, to sell to the customers you haven't met yet. And by the way, you're the architect. Your job is to make sure all these people are happy at the end of the day now. And when you're dealing with software on a, you know, planning horizon of maybe 5, 10, 20 years, who knows, you are going to need to have some kind of a plan. And, you know, planning has got a bit of a bad reputation in software because the Agile Manifesto came along and, you know, a lot of companies, they wrote a big plan, they tried to follow the plan, it didn't work because a 3-year waterfall software project is a very, very difficult thing to get right, is how I'm going to phrase it. And so these, you know, a lot of people were like, no, we'll be agile. We don't need to worry about planning too much. Now, Descartes, there's an old joke about Descartes that some of you may know. Descartes in a restaurant and he orders some tea without milk and the waiter goes to the kitchen. And the waiter comes back and he says to him, Monsieur Descartes, I'm very sorry, but we don't have any milk. Would you like tea without lemon? And one of the other things that not a lot of people know about Descartes is that for a while he worked as an agile consultant. And one day he's in with a client and, you know, they're struggling with this. And he says to them, you know, the Agile Manifesto says that we should choose to respond to change instead of following a plan. And the client says, oh, that's brilliant. We don't have a plan. And Descartes is like, sacre bleu. If you don't have a plan, how can you choose not to follow it? He's talking about the illusion of choice. And if you look at what the Agile Manifesto actually says, we have uncovered better ways of developing software. We have come to value responding to change over following a plan. There is value in the items on the right. We value the items on the left more. What that says is, have a plan. Plans have value. Don't stick to the plan if it clearly doesn't match the reality of what you're doing anymore. You know, the plan is a way of, at a certain point in time going, if we don't learn anything and nothing goes wrong, this is what we're going to do. But you will learn things and things will go wrong. And when they do, you want to be able to triangulate against your plan to see, well, where are we going now? Now, while we're talking about the Agile Manifesto, principles behind it. The best architectures, requirements, and designs emerge from self-organizing teams. Now, this does not mean that you can be like, right, you lot, self-organize, just get on with it. You know, self-organization means don't tell the team how to work. Don't, if they come up with ways of working that are clearly working for them, don't stamp that out and go, that's not how we do it. Do not inflict and enforce process. But you need something. If the team come to you and they're like, hey, we're not quite sure what we're doing here, you'd better have a better answer than I'll go over there and self-organize, or they're going to self-organize across the street into the pub. And in 2 weeks, you're going to be like, have you written any code? They're like, no, we're self-organizing now, boss. It's all fine. Now, let's talk about constraints. Here are the rules. No new hires, no JavaScript, no open source, no Microsoft, and no cookies. Now, do you want to work here? This actually is how Oracle builds software, I've heard. Don't quote me on that. You know, there are constraints. There are always constraints in software about what the systems can do and what the people can do. And that's a factor of your choice of systems, your choice of people, all kinds of things. You know, you have a beautiful org chart with 15 developers on it, and you go to your boss and you've only got budget to hire 3 people. That's a constraint. You've just identified a constraint, you know. You want to say build a mobile phone app for scanning RFID chips on passports, and then you discover that you don't have access to that API on the phone handsets. You have just discovered a technological constraint. Congratulations. You know, sometimes the constraints are obvious. Sometimes you'll discover them halfway through. Sometimes part of your role as an architect is to kind of keep an eye on the horizon and say, what are the constraints which are valid now, which may not exist anymore in a year or 2, 3 years from now? There was a couple of people working on the iPhone project when Apple were building that, who were literally kind of watching the state of touchscreen technology, of battery technology, of all these kinds of things, waiting for the point when the constraint didn't exist so they could be the first people to sweep in there. You know, before the iPhone, touchscreen phones, nobody wanted one. They were clunky, they didn't work. Everyone thought they were like the ticket machine at the railway station. Suddenly the technology gets good enough, the constraint has disappeared, and it was the Apple, you know, product engineering team who were like, that constraint doesn't exist anymore. So that's something you can bring to the table. Hey, this thing is changing. We can do this now. It's possible. It wasn't possible last year. Now we might be able to put it onto our plan. Now, a lot of the time, as the architect, part of your role is enforcing those constraints with your team. Let them self-organize. But when your whole team, you know, they go to a conference and they come back and they're like, hey, we're going to use the new shiny JavaScript framework. And you're the one who's like, no, there's a constraint here. We are still supporting this customer who's using Internet Explorer 10 or whatever version they're on now. We can't do that. We can't do that. And you know, that can be a difficult thing. I'll talk later about how you can manage that, because some of these constraints are things developers hate having to work with. They make it frustrating to try and build software. So there's our architecture. We determine the user needs, we meet user needs, and we do it within the technological and economic constraints. Now, there's 3 easy steps to doing that. Make decisions, communicate decisions, and then reinforce decisions. Now, you know, this is not a linear process. You don't make all your decisions now, you communicate them until the end of the first quarter, and then you reinforce them for the rest of the year. This is an iterative process. In terms of how I would approach making decisions as a software architect, it kind of boils down to understanding 5 things. First of all, you know, what have you got? Understand the technology that's already in play. Now, the best way that I've found of doing this is to look at the boundaries and the borders within your systems and understand the traffic. You know, reading the code, that's a very, very time-consuming way of figuring out how a software system actually works. You know, code in a repository is not the same as code that is running in production. If you look at the borders, you want to understand the traffic patterns. What are the connections, the data layers between your components? What travels across them? Here is an architecture diagram of something really simple. Now, website, I don't care. As an architect, .NET, PHP, Node.js, I really don't care what that website is built in, and the internet is somebody else's problem. But this little thing in the middle, HTTP, I want to know everything about that. How many requests per second can it handle? Is it load balanced? If it's load balancing, do we have some kind of sticky sessions? What are the HTTP verbs that are flowing backwards and forwards? What are the response types? Do we have content negotiation? Is it SSL? How high does it scale? You know, okay, 20,000 requests per minute. What happens when we hit 21,000? How is it going to fail? How is it going to fall over? You want to care about, it's Gene Kranz in Apollo 13. He's saying, I don't care what anything was designed to do. I care about what it can do. And sometimes you will find, you know, look at a system and somebody will be like, this is our high performance authentication platform. And you'll be like, high performance? Like literally I tried logging in on my phone and my laptop simultaneously and I got a 500 unavailable. That's not high performance. Sometimes it'll be the opposite. You'll go in somewhere like, you know, what do you got? They're like, oh, we don't really have a message queue. You're like, yeah, you do. You've got a Redis system running over here that's already configured. We have the connections for it. We can plug into that. Now, you will often find yourself in a situation where someone says, it's a greenfield project, you know, nothing to worry. No, there is no such thing as a greenfield project. There will always be things that exist somewhere in that application domain. Some of them will be things you can use. Some of them will be things you can't use because of security or politics or ownership or legal reasons, all these kinds of things. There will be the things you need to watch out for, the unexploded bombs, the project where 2 years ago someone suggested using SQL Server and the project failed for completely unrelated reasons, but now SQL Server is a dirty word around there, and you need to be aware of that, because if you bring it up at the wrong moment, you're going to make your own job a lot harder. There is going to be the rabbit hole. There is going to be the thing where you try and plug in OAuth, and you do OAuth for Facebook, and it takes a couple of hours, and Twitter takes a couple of hours, and LinkedIn takes a couple of hours. Then you got to do it with Apple, and it ends up taking you 3 weeks because you don't really know why. All the others were easy. You're going to disappear down these rabbit holes. Watch out for them. They will exist. And somewhere there will be the wreckage of the previous attempt to solve this problem. There will be the legacy system. There will be the thing that didn't ship. It's not greenfield because no one ever thought of it before. It's greenfield because no one ever managed to deliver it before. And you want to know where that is because, one, you watch out for it. Two, you might be able to salvage some ideas and stuff from it. What do you need? How do you ask the right questions? You know, every business in the world, you say, what does the software need to do? They come back with it needs to be fast and it needs to be secure. You've got to figure out how to have the kinds of conversations that turn those into meaningful metrics. Someone says, our website needs to be fast. Okay. How do you translate fast? Sit them down if you need to. Put some bandwidth throttling on a laptop and be like, all right, this is what the system feels like with this amount of latency. We will deliver, 40 milliseconds to the first page render for 90% of customers. That means for 1 in 10 people, it's going to feel like this. And maybe the business stakeholder will be like, yeah, we can live with that. Or maybe they'll be like, no, that's still too slow. You're like, all right. What about 95? Do we need to make it faster, or do we need to reduce the number of people who are affected? Because that turns it into a conversation about how much do you spend versus how much value do you get at the other side. And that's a business level conversation, which means it's not all on you to try and read people's minds. Everybody wants their software to be secure, right? Against who? Who are you worried about? Are you worried about botnets? Are you worried about somebody's, angry ex-girlfriend or ex-boyfriend going through their bag, getting their phone out, getting the two-factor authentication? Are you a nation-state actor that the Israeli Secret Service might be trying to break into? If you don't understand the threat models, if it's Chinese botnets trying to brute force your passwords, hey, if it fails twice, wait 30 seconds before trying again. The botnets get bored and go away. If it's angry ex-partners, come up with two-factor authentication that's not going to rely on people having their phones. Mossad are already in your systems. Stop worrying about it. Get on with your life. What can you build? What are your capabilities? What can your team do? And this comes down to what I call 4 Ps: people, patterns, packages, and process. People, who have you got? What do they do? And also, what do they like to do? One of the very interesting things that I've seen over the course of my career is you go to something like a Clojure meetup, and it's full of people who are like, well, I do PHP in my job, but really I want this. And then that same company appear on LinkedIn looking for Clojure developers. And you're like, but you've got them already. They were at the meetup the other week. How do you not realize this? Talk to the people. What are you doing right now? What do you wish you could do? What do you want to be able to work on? What are you interested in learning? Look at who you can hire. What are the easy languages, the well-supported patterns and platforms in your part of the industry? Patterns, to me, is about what is the fit between the kind of problems you're trying to solve and the solutions which are popular in the ecosystem that you've chosen. The best example I've ever seen on this is, Ruby on Rails is a very, very opinionated framework for building a certain kind of website. And it fits that pattern so well that you can build an MVC pattern website in Rails with a really tiny amount of code. If you try and do anything it wasn't designed to do, if you try and use Rails to do something that isn't MVC, you're going to have a very, very bad time. You're working on something that's going to be a Windows desktop application, you are probably looking at C#, .NET, something out of Microsoft, because those patterns are very well supported within that ecosystem. Packages. What can you get? What is out there if you need to do complex, lots of image encoding to different formats? Don't go for a platform where there is no library of image encoders available, because you're going to be reinventing the wheel a lot, and then it's going to slow you down. Look at the NuGet ecosystem or the NPM or Ruby Gems, whatever exists around that platform. If you need to do something like some crypto, you need to deal with zip files, what's out there that you can just tap into? And process is about reproducibility. It's about repeatability. How confident are you that when you put those people, that platform, and those packages together, and you're like, right, how confident are you that we're going to deliver this stuff by the end of the week? And if that gives you a regular cadence, then you can be reasonably confident that if you decide to solve a problem, you're going to solve it. If there's a lot of fluctuation, sometimes you run out of work, and other times something takes 6 weeks when you thought it was going to take 2. Those are indicators that you don't really understand some of the stuff you're up against yet. It makes it difficult to anticipate your own capabilities. What can you buy? If you can't sell it, buy it. Never use PowerShell when you can use MasterCard. You want your team building things that your business actually gets value from. Don't build your own cloud. Amazon have one, Google has one, Microsoft has one, Alibaba has one. Use their cloud because their cloud people are better than your cloud people. Unless you are going to try and compete with them, let them solve that problem. You solve the problem that you've got. Anything out there which is not actually part of a product that your customers are going to pay you for, if you can avoid, if you're not selling it, buy it. Find someone else that's done it and just pay them to solve the problem for you. And finally, what can you lose? Most systems have some redundancy and duplication involved in them. I once hit a point where I audited some software we had running at a place I was working. We had 12 different ways of sending email from the website. First one, someone built it. That was me. Second one, someone didn't know I'd already built one. They built a second one. Third one, somebody saw we had 2 already. They went, okay, we just build one when we need to send emails. Fourth one was built by some external contractors. Fifth one was in a platform that wasn't compatible with the others. Kind of not a big deal. None of them represented a significant investment in software development until someone said, we want to rebrand all of our outgoing email from all the different bits of the website. And we're like, that's a software architecture problem now because we got 12 different email relay systems. So look for opportunities to rationalize and eliminate duplication. Now, decide what to do. Now I said here, that's the easy part. That's maybe underselling it a little, but you immerse yourself in all the stuff I just talked about and good ideas will start to emerge and you'll come up with some, you'll have a plan. You'll think, well, if we investigate this, that'll work for the way we want to approach this system. I think we can do that quite easily with .NET. We can use Dapper over there, a message queue for this part. You'll have those ideas, Once you've had the ideas, then you got to tell everyone else what your ideas are. And this is where it gets complicated because in your head, your software architecture is perfect and beautiful and elegant and it scales for hundreds of thousands of users. And then you sit down with your team and you're like, right, let me show you the diagram of the new architecture. And the team look at it and they're like, what? It is very, very hard to explain to people to get the idea out of your head and into somebody else's head. Now, in software, we often fall back on using diagrams. Diagrams are a kind of, accepted way of communicating designs. And let's go back to talking about construction for a second, because when somebody says we're going to make a building, they come up with a bunch of diagrams and drawings and elevations and plans and sketches, artists' impressions, and the fidelity of these is optimized for different things until you reach a point where you have a drawing or a design and you're like, I can picture what this building is going to look like. And then you look at the building and you're like, yep, that's pretty much what I expected. Now, when we create plans and elevations and schematics of software, we come up with stuff that looks like this. And does anybody out there, just only take a look at this for a second, and then drop a comment in the YouTube chat there for how much money you'd charge me to build this system. If I said to your team, go and build me one of these, how much would you quote for that job? Because you're probably thinking, okay, I don't know. What does that mean? Now, this is a industry standard official published notation for documenting software systems. Does anyone know how to read it? I learned how to read this in school and then I promptly forgot about it. This is a thing called the Jordan-Demarco notation. It's a way of documenting data flows in software. We've got databases and we've got functions and we've got input-output. So now it's all crystal clear, right? You totally understand how it works. No. All right, well, let's start adding in some comments. So what is Excelsior here? It's a SQL Server database of customer details. And Mercutio, what's that? It's a .NET service that populates email templates. And we got this thing over here. Okay, yeah, I was right. That is a file share on a Windows server. Why it's the dollar file share from SMB, we don't know. It just is. Okay, Mandrill is someone else's SMTP relay service. That's fine. And Norman is a .NET app that sends emails. Why is it called Norman? Because Norman Mailer. All right, that's a real example. Now, by using your Demarco notation, we have constrained ourselves to only being able to imagine 4 different kinds of things. Scrap the notation. It's not like most people know how to read it anyway, and it's limiting. Rectangles and lines and boxes, and if the lines and boxes aren't meaningful, let's put on something that makes them meaningful. We're going to drop on some clip art here. We're going to add some color coding. We're going to add some. Now, what does all this stuff mean? Well, you don't have to remember it because I'm going to include the key on the diagram. And now I can give you this, and you can look at this and, you know, start making some reasoned decisions about, all right, that's a SQL database, that's a ADO.NET records, there's an SMB file share here. The last thing that I'm going to do at the moment, there's another good principle of diagrams. Even though we all have color, high fidelity displays, make them work in black and white. Imagine someone printed them out and photocopied them. We've got these arrows on here that aren't actually terribly useful. Let's add more detail. Keep documenting things until kind of all the questions that you think when you look at the diagram, the answer is on the diagram alongside it. So there is our diagram. Now compare that to that one. The one on the left, that looks nice, right? That's elegant and minimalist, like the ones in the textbooks. The one on the right looks a little bit noisy and cluttered, but real life is noisy and cluttered. Real systems are noisy and cluttered. This is one extract from a real set of architecture diagrams that I did years ago as part of an integration project. And, you know, it's full of stuff that you won't find in any engineering or, you know, software architecture textbook anywhere. Like, you know, I've got these little ad hoc lines and arrows on it saying, oh, when somebody presses this button, this thing happens. And here is the legend, which shows you what all the different colors and things are. And there's annotations on all of them. And there's a note here about a big red button that does an on-demand sync. Real life looks like this, you know. Don't get too bogged down in trying to make the diagrams look minimalist and elegant, because the systems you are dealing with are probably not minimalist and elegant. If you want pretty diagrams, you got to start with pretty systems and pretty code and then just document what's accurate. If the diagram's messy, there's probably complexity in the software that you want to address. So one last thing I want to say on the subject of diagrams. Here are 2 software architecture diagrams. One of these is something called the Hexagonal Architecture. Take a moment, look at them. Which one of these do you think is the Hexagonal Architecture? I'll give you a clue. It is not the one with the hexagons in it. The architecture on the left is the ports and adapters pattern. We have our core logic in the middle, and all of its communication with external services is by defining ports, a set of interfaces, and then adapters that connect those interfaces to things out there in the real world. It's called the Hexagonal Architecture because the book that popularized it had a lot of hexagons in the diagrams. The thing on the right is meaningless. It is nonsense. But at some point, you will be in a situation, maybe not as clear-cut as this, where somebody puts up something like that and says it's a hexagonal architecture. And never be afraid to be the person. You don't know who else in the room is thinking, I don't understand this, but I'm sure I can figure it out later. You don't know who thinks they understand it and their understanding is completely backwards. You can be the person who says, just hang on a second, can I just check the hexagonal architecture? We're talking about ports and adapters there? And they'll be, yeah, and you're like, okay, can we just sketch out the ports and the adapters? And you can kind of diplomatically steer that conversation towards something that is meaningful, that everybody understands. So we've made our decisions, we've designed our system, we've come up with ways of communicating those designs with the rest of our team through diagrams, documents, prototypes, all these kinds of things. The next thing on our roadmap, on our plan, is we got to reinforce those decisions. We need to help the team get it right. And there are 2 different kinds of right. There are valid, or there is valid and there is verified. And validation is, you know, is the thing we are building really what the world needs? Is it the correct product for our company? Is it the right solution for this problem? Now, in architecture, that's hard because often it'll take years before you discover whether you made the right call or not. And you won't get them all right. The things that you got right, you probably forget about because you don't notice them anymore. The things you got wrong are the things which prove expensive to fix later. So always kind of check in and take stock and think, no, let's keep a list of all the stuff we did which worked. Verification is the thing that you're building, does it match the design? Does it match the diagrams and stuff? And in real life, you can take your blueprint and your architecture diagram, and you can take your finished product, and you can kind of compare the 2 side by side and go, yep, that looks pretty good. That's close. We did good. Nice work. With software, how do we hold the diagram up to the finished product? Well, that, yeah, okay, there's one view of it. That does not look much like the system that's running in production. Maybe I can have a look at the Azure dashboard. Again, it's interesting. It doesn't look like the design. What about the Team City build status? Does that? No, I know. I'll look at the code. I'll open up the code and I'll look at it in there. And we have these 4 different valid views onto a software system. How do we decide which of these are valuable, which ones are relevant, and what it is that they actually tell us? Now, reviewing code is a bad way of reinforcing architecture. Something I learned the hard way is that if you like, okay, I'll do the architecture, I'll do the design, I'll tell you, and then I'll review all the code. One, you become a bottleneck. Your team are going to write more code than you can read. And it's easier to write code than it is to read it. So actually, you've got the more difficult job in that. You are going to struggle to keep up with the amount of code. You are going to find it very, very hard to see the stuff that matters without getting caught up in little details of style and syntax and tabs and spaces and those kinds of things. And you're going to end up burning out on the days where it's 7 o'clock at night and you've got to go home, but there's 6 pull requests waiting for review. And you end up in this, like, I reviewed your C# code and I still don't know what it does. And your lead engineer is like, dude, my team switched to Haskell 2 years ago. The other problem with reviewing code is when you just glance at a chunk of code. Look at this. This is it's a customer repo, and we can have a look. A customer repo has an identity map of customer, and we got a get customer method map find by ID. All right, that all looks pretty good. Now, this code doesn't tell you anything other than the choice of the names that was made by the person who wrote it. The person who wrote this, we had a meeting and we're like, we'll use an identity map and a repository pattern. And somebody went away and implemented it. Now, maybe they got it absolutely right. Maybe this is a beautiful, elegant, minimalist identity map repository implementation. Or maybe they're just like, oh, I should call this thing identity map because that's what we said in the meeting. And the implementation under the hood, it's a direct database connection. There's no caching. The customer repo here could be just about anything. That find by ID method, you don't know what it does, you just know what it's called. Relying on names to review an unfamiliar code base can be like you're wandering around an unfamiliar city and it's late at night and you see a sign that says luxury hotel and you're like, it must be good. It says luxury hotel. And you wake up in the morning and you're like, I probably should not have relied too much on the naming. So what can you do to guide your teams along the correct path when it comes to implementation details? Well, one of the things you can do is to align the people and the technology with the components. Sometimes this is obvious. You put all your JavaScript and your HTML developers in this room, and you put all your C# developers in that room, and then the architect designs the APIs that connect those 2 rooms together and connect those 2 teams together. You can take this thing even further. You can get to a point where you're like, we got an Angular team here in London, we've got an F# team down in Romania somewhere, we've got an Android team out in Portugal. This is something called domain architecture isomorphism. It's the inverse Conway maneuver. Basically, you're taking Conway's law, the observation that the software you build is going to reflect the communication structures of the people and the teams who built it. And so you start with your software architecture and you're like, right, where are the communication boundaries in the system going to be? We want module A talks to module B. All right, let's take the people who are building module A, put them over here. People who are building module B, we'll put them over here. We will enforce that abstraction between the 2 components by creating a physical abstraction between the 2 teams. Now, this has obviously got a little bit more difficult now that so many people are at home, they're working remote and they're on their own. So look at the Slack workspaces and the channels you got set up and the weekly Zooms and stand-ups, and figure out how can you create high bandwidth communication between the people whose code is tightly coupled and a lower bandwidth communication between people whose code should be loosely coupled. Now, as an architect, one of the ways that you can encourage these kinds of separations, you got the 2 teams, one of them's front end. They need to write code that's going to talk to an API server. The other team is back end. They're writing code that responds to an API client. So sit down with someone from the front end team and be like, right, we're going to write some fake JSON. We are going to build a fake API server so your team can start calling it and getting results back. Then you go over to the back end team and you're like, right, I'm going to spec the tests that hit your API. I'm not going to write the code itself. Together, we are going to develop the test suite, the integration tests, which validate the behavior of what's happening behind your API. Then You take those bits out, you plug these two bits into each other, and you, the architect, you keep an eye on that connection in the middle. Because you should have a pretty good idea, what kind of traffic are you expecting to see? How much? How big are the payloads? What are the requests and responses and data types that are going to be flowing backwards and forwards across that? Sometimes this is ad hoc. Sometimes you start, adding monitoring systems and building dashboards and stuff. And that brings me on to a question that comes up a lot. Should architects still code? Yes, they should. I absolutely believe that when you stop coding, the way you think about software starts changing, and eventually you start making decisions that don't make any sense, and you struggle to reinforce and encourage developers to work with those decisions. You got to keep the saw sharp. You want to stay hands-on so you know what's actually going on, but I don't think architects should be coding features on, customer-facing products, because there is always going to be a day where you want to change something, and you can change it in code right now by yourself, or you can wait for everyone to get back. You can have a meeting, or you can send around a document, and you can try and change the design. And the temptation to be like, I'll just change it. And then the design doesn't match the code anymore. And the people relying on the design are like, well, which one's right? And you're like, oh, we'll just update the design. And that's the start of a slippery slope, and eventually you're back to doing all the stuff yourself, and everyone else is like, we just have no idea. They're off doing their own thing, and we're self-organizing across the street, or we'll be back on Friday when the architect has finished building the product. Yes, you should still code, but the best way I found of staying hands-on is that the architect manages the dashboards. You build the displays that show everyone what's happening. You build the tools that you need and that the business stakeholders need to see how well your products and systems are performing, to see what it is that they're doing, see if there's any problems, anticipate when you're going to need to upgrade infrastructure, all these kinds of things. There's another thing that you can do, which is very, very easy to forget about, is you're often, as an architect, you're going to be the conduit between some business requirements and the development effort. And in a lot of organizations, there will be business decisions that the developers don't like, because the developers are like, we want to build our own system. And the business is like, we are going to buy SharePoint. And the developers are like, we don't want SharePoint. And often one of the difficulties there is the decisions that make sense, the things which are the right business call, they disappear from the development radar because they're not a software problem anymore. And so part of your job is to, come back to the team. Years ago, I did a dynamic CRM integration, and the team were kind of, Dynamic CRM is a kind of tough product to integrate with. It has some quirks, shall we say. And the team were getting a bit fed up. And after a couple of months, I said to them, do you remember every single Friday afternoon, we used to have to spend 3 hours pulling spreadsheets and sending them to marketing so they could send out all the weekly emails and stuff? And everyone was like, oh yeah, I forgot we used to do that. And you're like, and notice how we don't do that anymore? And at that point, the devs are like, actually, maybe these business level decisions do actually have some benefit. Maybe there is some stuff in here that is useful for all of us. Now, I just want to leave you today on the subject of architecture. There's a parallel between construction architecture and software architecture. But construction architects, 5,000 years ago, they came up with this. They came up with a pyramid, and they went, all right, that's a start. And they started figuring things out, and new materials, new ideas, new techniques. And 5,000 years after the pyramids were built, somebody went, hey, what if we do the same, but we only make it out of glass? Now, software architecture, we've only been doing this for 25 years. It's taken them 5,000 years to go from the stone pyramid to the glass pyramid. Check in with us in 5,000 years and see how the state of the art has evolved when it comes to software architecture. Thank you very much, CodeCamp. Any second now, there will be a little voice in my ear. Any folks got any questions? Sing out, stick them on YouTube.
That voice is Florin.
That voice is Florin. Yeah, right. Yeah, very, very nice talk. I really enjoy that. It's but as all architectural talks, I think it's just the beginning of an entire conversation. To be honest, I was thinking of the expression, the art of possible, which needs to be like a skill for the architect. And if you could expand a little bit of how to grow that skill of bridging the business and the teams and other stakeholders.
It's difficult because it's one of those things developers and the craft of software development, it's an easy thing to get wrong until you get it right, because you can do it by yourself in private when no one sees you. The compiler is infinitely patient, and you don't push your code to GitHub until you're happy with it. Anything that involves people and money becomes far more complex, because you can't just keep trying it over and over again, because you burn credibility and you burn through budgets and stuff. I think the best way of doing it is to watch how other people interact. And, look at the patterns, look at the people you're working with. When it comes to experimenting with systems, there's a bunch of stuff you can do there. But then you got to think, okay, I found this wonderful piece of technology that we didn't think was possible, but it turns out we can do it now. What's the right way of bringing that to the table? Who do I show it to first? The iPhone example that I used there was a person at Apple. Steve Jobs is this very, very infamously, impatient character. He's, in some ways, I don't doubt it, he was a visionary and a genius at product design. But in other ways, he sounds like a terrible person to work for, because he would get angry and he would shout at people. And there was literally somebody at Apple, and their job every morning was to check in with Steve and just kind of figure out what kind of mood he's in. Because there was the team who were working on multi-touch. They had the first multi-touch touchscreen system, and they were like, we think we can put this into some astonishing devices. They had a prototype, and they're like, look, if we tell Steve about this before it's ready, he's going to throw a fit and yell at us and fire us for wasting his time by showing him something that's not ready yet. And if we leave it too late and somebody else beats us to market, Steve's going to fire all of us for not telling him about it earlier. And there was somebody whose job was to kind of watch Steve and what? It's like, okay, today's the day. I think today is the right day to tell Steve Jobs that we've invented multi-touch. And, other teams at Apple, the book about the development of the iPhone is fascinating. I'll drop the link in the chat to the book. It's a brilliant insight into product development and digital team management and stuff. But, the art of the possible is not just what's possible, it's how do you get the right people on side? How do you make sure that the message you're trying to send doesn't come through as, because often when something is new, people who have a loyalty to the old system could be threatened by it. And it's like the waves of Visual Basic programmers who are like, C# is wrong and bad, and it's like, well, it's just a programming language, but you've worked hard to get really good at Visual Basic, and now we're telling you it's not cool anymore. You can't do that anymore. And as I was doing some stuff at an event earlier today, talking about jQuery and JavaScript and web components and Angular, and the art of the possible, when something used to be impossible or something used to be difficult, there were probably people who, in some way benefited from the impossibility of that thing. And now you come along and you say, hey, by the way, we can do this thing now. That can ruffle some feathers. But yeah, it's difficult. And I don't think there's any fast track way of doing it. I think it's something that you, over a period of,
patient and to practice and to accept the explosion after saying a no, and then building upon that type of knowledge, right?
And I think part of it is also be prepared that you're going to learn there are things that you struggle to do well, and there are things you just don't want to do on any level. And part of it is about finding people and processes that complement the things you're good at by letting other people bring their own strengths and ideas and things to the table, so that you get a sort of more stable, diverse set of opinions and ideas coming out of that collaboration.
I think this sort of conversation between, let's say, the ones that we're having now works really well. So it's about learning and exploring and discovering the system while building it. But then sometimes you end up with a stakeholder that's totally from a non-technological area, doesn't understand, and starts comparing it with things that he just buys out of the box, or even building a house, but even there are delays.
So I think there is an art to being able to take somebody else's metaphor and run with it. And, something I remember, you talk about building a house there. Construction, parallels between construction and software are, all over the place. And they work really well right up to the point where they don't. And I remember saying to someone once, like, doing a code review is like, imagine you hired some people to build you a house. And they say, all right, the house is done. And then you say, right, I want to see it. And they're like, okay, you put the blindfold on, and they take you into the house, and then they put like a, pair of those cardboard tubes from toilet paper. They're like, you can look through the tubes. So you need to inspect the whole house now, but you can only see that much of it at one time. Review the whole house. Tell us whether there's any problems. And so you're going to look at it, you know, all right, well, there's definitely a wall there. And it's like, did you check the entire wall? It's like, what? And then you take the cardboard tubes off and you're like, oh, there's no roof. How did we miss the entire roof? You know, when you're talking about construction architecture, those kind of things are obvious because they're big and they're tangible and you can hit them with a stick and see what they sound like. In software, it's easy to forget to put the roof on the house just because nobody ever noticed that it wasn't there, you know. And you know, if somebody else brings a metaphor to the table, you can normally try and find some way of being all right. Okay, let's talk about software as if it was motorcycle racing. Let's talk about software as if we were, you know, rescuing cats. Whatever they bring to it, and you try and find a way of bringing that around so that they feel like, okay, this is a connection that came from something I brought instead of someone telling me, no, we don't like your ideas. We're going to use my ideas instead.
Mm-hmm. Yeah, it's really important to find the common ground and find the common wording and metaphors and so on. So, the other point that I would like us to tackle a little bit, since we're discussing about the thing that's hard to change, is the fact that architecture is, well, all about making decisions.
Yeah.
Right. And then there is this concept, the last responsible moment for making or considering a decision, which of course
everybody knows when that is.
Yeah, everybody knows when that is. And there is another tricky one, because now in the industry we are also discussing about not the last responsible moment, but the most responsible moment.
Yeah.
And there is here like a I don't know, like a trigger for a one-day conversation, to be honest. So the last or the most responsible moment. But anyways, the last or the most, how did you perceive it, or how do you?
A part of that is, I think, just about, there's an anti-pattern I see, which is where somebody is given the responsibility of making a decision, but they're not given the autonomy to do that. You know, and it needs to be about, look, I'm going to make this call, and if it's right, then I was right, and if it's wrong, then I was wrong. But if I was wrong, don't kick my ass about it. If it turns out I was wrong, I will figure out a plan to kind of follow through on that and try and fix it later. And, you know, sometimes you got to accept pressure. You know, business pressure is about time and budget normally, and quality, but time and budget are the two that seem to be a factor everywhere I go. And keep track of how much time you've saved and how much budget you've saved. And, you know, sometimes that can backfire a little bit, because you're like, okay, this is how much this thing would cost if we did it in this kind of certain way. We need to make a decision now. We can't postpone it any longer. I'm going to go for the cheap way, but please keep all this in some kind of metaphorical bank somewhere, because we may need it back later if it turns out this was the wrong thing to do. And then you start working with it. And then if it turns out it's right, it's like, brilliant. Okay, I'm confident that we made the right call there. And, you know, there's a thing called the opportunity cost and the cost of delay. You know, opportunity cost is, well, what else could we have done instead of this? And cost of delay is, you know, what's the difference between having this feature now and having this feature next month? And, you know, you read up on some of this stuff. There are people who literally track this kind of stuff for a living. That's their mojo. That's what they do really well. But a little bit of awareness about those kinds of things can be really helpful in helping you just figure out in your own head, can I put this off for another week? I still don't kind of know what's right. But my gut feeling is telling me that we should probably be using, I don't know, Redis instead of Cosmos DB for this piece of the system. Do we do another week and do a spike on Redis and a spike on Cosmos? Do we just go with Redis? And then sometimes it's be like, well, you know what? It would only take a week to do Redis anyway. So how about we do the spike? And if the spike is good, then that becomes production. And then there's the like, oh no, we said we'd never do that. We always said we'd never deploy the prototype. And it goes round and round and round. But you know, it's difficult. It's if it was easy, everyone would do it without making any mistakes. And
yeah, like I said, you would have the programming or the writing software Bible, and we'll follow it step by step, and that's it. Well,
all right.
It's been really, really fun, Dylan, once again. And
thank you very much for having me once again.
Yeah, we don't have a lot of questions for the audience, but we do have messages that, it was a great presentation. So that means people are with us.
Yeah, and yeah, we had like a lot of food for thought.
Cool. I'll drop sort of the folks who are watching on YouTube, I'll drop a couple of links in the YouTube chat. The iPhone book that I mentioned briefly there, that's an interesting one to look up. I also saw someone asking about the retro wallpaper, so I'll send you a link to the place where I get my wallpaper from, because the artist who does it is brilliant. So cool. All right.
And in terms of music now,
yeah,
what did you listen recently?
So if everyone here goes and listens to one piece of music because I recommended it, there's a band called Arena who have just done a synthwave cover of Dreams by Van Halen, which is on YouTube and it is on Spotify, and it is absolutely fantastic. And I recommend everybody go out and look up Dreams by Arena and listen to that, because that's my jam at the moment. A lot of Sabaton, the new album by Thunder, and last night I was up late making slides and listening to George Thorogood and a whole bunch of American blues guitar players. So a lot of time to listen to music.
Excellent. Yeah, I cannot play it now, but I will do immediately after the show, right? Because I don't want our show to be banned from.
No, you don't want that.
Yeah, exactly. Dylan, thank you so much.
Thank you so much for having me. Take care, everybody.
And until the next conference, we'll see each other at the masterclass we're doing soon.
We will indeed. Yes, we're doing that. It's in May, isn't it?
Yes.
Introduction to Distributed Systems. It's 2 days of hands-on. 2 days, 1 day? It's hands-on.
One day.
Yeah, it's the 1 day fast track. It's REST, HTTP, GraphQL, gRPC, SignalR, and EasyNetQ. And it's basically building a system in a day that has all these different microservice components. They all talk to each other. It's very, very hands-on. So everyone who comes along is going to be writing code, and we'll be bouncing API calls off each other's computers across the internet and all this kind of stuff. It's going to be a lot of fun. So yeah, check that out. Get tickets. Join up. I'll see you there.
Super.
Thanks a lot, Dylan.